Hello everyone. Today we will discuss about interpolation, which is very important topic in numerical analysis. At first, we have to know what is interpolation. Interpolation is basically a method by which we can approximate a function fx by a known function, and the analytic form of fx is unknown and fx is known for n plus 1 distinct values of x, that is say x0, x1, x2 up to xn. Now, the definition of interpolation is: interpolation is the principle or method by which we can approximate a function fx by a function phi x which is known. Here fx is unknown but phi x is known, and we approximate the function fx by a known function phi x. Now let fx be a unknown function which is known for n plus 1 distinct values of x, that is say the n plus 1 points are x0, x1 up to xn, and f of x0, f of x1, f of xn are functional values. That is, the analytic form of the function fx is unknown, but we know the function for n plus 1 distinct values of x. Now here we also assume that fx is continuous and differentiable sufficient number of times. That is, we assume that fx is continuous and differentiable sufficient number of times. Now, our problem is to find the value of fx for a given value of x, say x equal to capital X, where capital X not equal to small xi for I is equal to 0, 1, 2 up to n, and minimum of x0, x1 up to xn less than capital X less than maximum of x0, x1 up to xn. Since fx is unknown, so we approximate it by another known function phi x in a manner such that f of xi is equal to phi of xi for I is equal to 0, 1, 2 up to n, that is f of x0 is equal to phi of x0, f of x1 is equal to phi of x1 up to f of xn is equal to phi of xn. Now we have to find the value of phi capital X, and this is the approximate value of f capital X. That is, we then find the value of phi x at small x is equal to capital X, and this is taken as an approximate value of f of capital X. This method is called interpolation. Therefore, by interpolation, we can find a value of a function fx at some point small x equal to capital X, where the analytic form of the function fx is unknown, but the functional values is known for n plus 1 distinct values of x, that is x0, x1 up to xn, and the capital X belongs to open interval minimum of xi and maximum of xi. Now, in interpolation, we can approximate a function fx by any function phi x which is known, but when we approximate the function fx by a polynomial, then the interpolation is called polynomial interpolation and the polynomial is called interpolating polynomial. So, when phi x is taken as a polynomial, phi n x is equal to a0 plus a1x plus a2 into x square plus up to an into x to the power n of degree n at most. That is, if fx is known for n plus 1 distinct values of x, then the degree of interpolating polynomial is n at most. Now then, the interpolation is called Polynomial interpolation. And phi n x is called interpolating polynomial. The interpolating polynomial. Now, the existence of the interpolating polynomial is based on Weierstrass polynomial approximation theorem. This theorem says that Weierstrass polynomial approximation theorem says that any continuous function fx in open interval AB can be approximated by a polynomial px which satisfies the condition mod fx minus px less than epsilon for all x belongs to closed interval AB where epsilon greater 0 be given. That is modulus f of x minus p of x less than epsilon, that is px minus f of x less than epsilon. This implies minus epsilon less than px minus fx less than plus epsilon. Implies f of x minus epsilon less than px less than f of x plus epsilon. Here is the figure. Here this is p of x, this is f of x, this is f of x plus epsilon, this is f of x minus epsilon. Now here f of x is equal to p of x at the point x0, x1, x2, x3 up to xn. That is f of x0 is equal to p of x0, f of x1 is equal to p of x1, f of x2 is equal to p of x2, f of x3 is equal to p of x3 up to f of xn minus 1 is equal to p of xn minus 1 and f of xn is equal to p of xn. And p of x lies between f of x minus epsilon and f of x plus epsilon. That is all for today. If you like our classes, please do like, share and subscribe our channel for more classes. Thank you so much.